right, in this video we're going to talk about a method called integration by parts. It's basically undoing the product rule, or if you've got two things being multiplied together, how do you find that antiderivative? So let's look at the product rule just as a review, where if we find the derivative of u times v, two functions being multiplied together, we used f of x and g of x in the past, but we'll use u and v to represent these functions. So we can write this as the derivative of u, which is du over dx, times v without changing it, plus u times the derivative of v, dv over dx. To make things a little less formal, what we'll do then is what most people do when they look at integration by parts. They write du over dx as u prime times v plus u times v prime. So now if we work this backwards, in other words, if we find the antiderivative of this, so we're going to say, what is the antiderivative of this derivative? And then what would be the antiderivative of this side? So we'll just integrate both sides. I can separate this into the right side. I can separate it into two different integrals. And that's exactly what we want to do, is separate it into two different integrals, because we want to look at each part separately. So we know that the antiderivative on this left side here, the antiderivative of the derivative of u times v, those two actions undo each other and get us back to u times v again. And then these two are like this. So the question is, if we have a product, so we have two things being multiplied together, how do we find the antiderivative? So if we manipulate this equation that we just found, and we isolate one of those integrals, so the rule of thumb is that we isolate this integral, the u times v prime. So if we say we have an integral that is u times v prime, if we're isolating that, we can find that antiderivative by taking u times v, the original function v, and subtracting the antiderivative of u prime v. So we just manipulated the product rule to say, all right, if we want to find the antiderivative of one of these products, how would we do that? And this is how we do it. So this is the formula. This is integration by parts. Now we're going to look at a couple examples to see how we might be able to use this. Okay, it's going to be easier if I show you than trying to talk about it. So with integration by parts, we have, let's look at this one. We've got two functions being multiplied together. We can try and think about all of the methods that we have worked with so far, and this one doesn't really match up with any of them. If I distribute the e to the x, that'll still give me a product that would be 4 times x times e to the x, so that's still a product. So there's u substitution is not going to help. If I let u equal 4x plus 7, du is 4, and e to the x has nothing to do with that. So this is a product of two things being multiplied together. And typically then what we do is we say, all right, this is a product, just like we did up above. And one of those will be the u part of this antiderivative, so the u part of this, and the other one will be the v prime part of this. Rule of thumb is we let the less complicated part of the function, so in this case 4x plus 7 is not as complex as e to the x, we let that be the u value. And then we let the more complex part of this be v prime. So we're kind of breaking down the left side of integration by parts, and we're saying we're going to let one of those parts be u, the other part be v prime. In order to find the antiderivative then, we're going to need to figure out what u is and what v is, and we also need to know what is u prime and v. So let's do a little bit of math over here on the side. I just assigned u to be 4x plus 7, and you'll see in a moment why that's going to be a convenient value to choose. In order to find the antiderivative of this, then, I will need to also know what u prime is. So the derivative of 4x plus 7, and that's 4. Okay? I know that v prime is e to the x, so I need to figure out what the original function is. In other words, what was the antiderivative of v prime? And the antiderivative of e to the x is e to the x. Okay, let's rewrite this. Now, when you rewrite a problem with integration by parts, always start with rewriting the original equation. And trust me on this, you'll see an example where this is going to come in handy. So always start by rewriting the original integrand. And now I'm going to break it down working backward from the product rule. So the product rule, or the integration by parts, says multiply u times v. So in our case, I'm going to multiply u, which is 4x plus 7. And we found v to be e to the x, minus the antiderivative of u prime. Now here's why we let u equal the less complicated value. Because if we let u equal this polynomial 4x plus 7, the derivative of that is just a constant. The derivative is 4. So now when I write that in my integral, if I write u prime times v, I still have a product here. However, it's a product with a coefficient, or with a constant. So now this is something we can integrate. So the antiderivative of 4 times e to the x is 4 times e to the x. So we've just worked backwards from this product to say now that we can find the derivative of that original thing. The antiderivative for e to the x is 4e to the x and plus some constant. Using integration by parts, we just found the antiderivative of that product from up above. Okay, let's try another one. Number 2. Let's do this one. We've got x times the sine of x dx. Okay, in this case, you know what? I'm going to let you go try. I'll pause. Go try. Okay, welcome back. If I let u be the less complicated function, so if I let u equal x, and I'm going to let v prime be the more complicated function, so u prime will be the sine of x. Then I can write u prime as 1. I can write v as the antiderivative of sine x, so that'll be negative cosine x. Now I can rewrite this as u times v, so that's negative x cosine x minus the antiderivative of u prime times v, so the antiderivative of negative cosine x. If I now integrate, actually what I'll do first, got to really be careful with these minuses. This minus and that minus really becomes plus the antiderivative of cosine x, and then the antiderivative of cosine x is sine x plus c. I'm going to make these videos a little bit shorter to smaller chunks, so I'm going to stop right here while things are just a little more straightforward. The next video is going to start looking at some strange things, so some weird anomalies.